Welcome friends, let's take a look at finding the real part of z squared. So z squared like that. So the real part of z squared is what I'm going to find. Now remember that z is x plus yi. Okay, so I remember is the imaginary unit, and then basically the x and the y are just some real numbers like 5 or 10 or whatever they happen to be. Okay, first work on expanding z squared. You can do it together within the RE. It doesn't really matter very much as long as you take it at the end. So what I would do is say RE of z squared will become the real part of following x plus yi quantities squared. From here, there are varying levels of detail that you can show if you like. So you can say equals the real part, and then this really means x plus yi as a reminder times x plus yi. Now let's review some basic things here. This is the red x. I'm going to make this one green. Okay, now look very careful. I'm going to make this part bold, and I'm going to make this part just stay as it is, okay? Not bold. So then what you have is you FOIL out. So you're going to have the real part and you FOIL out. So you're going to have x in red times the x in green. Color code, pay attention carefully, focus on it. As you do that, you'll learn it better. And then plus x times yi. So here, this is the red x, and this is the yi that's not bold. Okay, then plus yi. Now this is the bold yi. Look very carefully at it. Focus. Math is best on like mind like a laser beam. And then x here. And at the very end, you have plus yi, the bold one that is, times the yi that's not bold. So this step is FOIL, and then you have the following after that. The real part, and you work out. So x squared plus xyi plus yix if you like, plus y squared and then I squared. Then we continue here, and then from here we have the real part of x squared. Then you double the two green ones, so 2xyi. Right here, there are two of them. Plus, and then y squared, and I squared becomes -1 right here at the very end. So then you continue the real part of x squared for now, plus 2xyi minus y squared, and then you have the real part of x squared minus y squared plus 2xyi. Okay, so now this part is the part attached to I, and now this red part, that is the real part because it doesn't have I in it. So the output at the very end is x squared minus y squared. I really should pause the video, or 10 seconds, I don't know, and figure out what the imaginary part is. You really should do that, but I'll do it. So the imaginary part of z squared you could write as, again, to emphasize using this one, you're going to say the imaginary part of x squared minus y squared plus 2xyi. It's this thing here. I'll make it bold because that's the part that is attached, as you can see, to the I. So it just comes out as 2xy. So if this is helpful, please be sure to subscribe, to like, to share, to check out the other videos related to complex analysis on this channel. My name is Tom. I'm a college instructor at NYC. Let me zoom back out here so you can see it all from top to bottom. Maybe a little more. That's pretty good, actually. So thank you so much for watching. I'll see you in another video.